Hi everyone, I'm Mr. Chia from Triple A Teaching Center. Today I will start a topic called solids, liquids, and gases. We will learn about how to state the distinguishing properties of solid, liquid, and gas. And we need to know how to describe the structures of solid, liquid, and gas in terms of particle separation, arrangement, and motion. So before we start, let's learn what is matter. Matter is the everything around us has mass and occupies space. For example, like milk. It has mass and it occupies the space of the cup. Car also, it has mass and occupies space too. Smoke, even smoke has mass and it occupies space, so it's matter. Even air also. Okay, let's see. There are three states of matter: solid, liquid, and gas. For example, solid, the simple example I can give is ice. For liquid is water. For gas is air. So let's see what are the structures, what are the properties of solid, liquid, and gas. For solid, for example, like ice, it has a fixed volume and a surface boundary. You can see it has a fixed volume and also a surface boundary. Means that for surface boundary, right, means that like you can draw it right very clearly, like this surface boundary. You can draw it. You can see the surface boundary. You can see the surface lines. It also has a definite shape, right? Cube. Okay, if you zoom in the solid, you can see the particles inside are tightly packed and they are vibrating because they cannot move because it got so little space, right? No space at all, so it cannot move, so it can only vibrate. So this is solid. So for liquid, for example like water, it also has a fixed volume and have a surface boundary. And if you zoom in the liquid, you can see that the particles, because there are a bit of spaces compared to solid, so the particles take the shape of their container. No definite shape. Means it can move according to the shape of their container. For let's say this picture, there are different sizes and different shapes of containers, right? So the liquid just follow the shape of the container. Okay, let's say the container is cube in shape. So the liquid is just cube in shape. Just follow the shape of container. Let's say the container is in cylinder shape. So the liquid is just cylinder shape. It just follow the shape of the container. So it has no definite shape. If you zoom in, you can see the particles move around and slide past each other because they got spaces, a bit of spaces, so they can move around a bit. Okay, this is liquid. So for gas, for example like air, it has no fixed volume and no surface boundary. Okay, it's like you can't draw air, right? You cannot draw air, so it has no surface boundary. And if you zoom in, right, the particles inside the gas can move around freely because it got so much of spaces. They are very free, they are very random, so they can move up, right, left, down, whatever they like, can move around freely. So they can also take the shape of their container also. No definite shape. Like if you use a bottle, cylindrical bottle to fill up the air, so the air just follow the shape of the container, cylindrical bottle. So it has no definite shape. Remember this. So this is gas. So let's see. Just now we learned about the properties of solid, liquid, and gas, right? So we need to know the structures of them in terms of particle separation. Separation means that the particle how they separate. It's like they like separate, no separation at all, just a bit separation or very far separation. In terms of particle arrangement, how they arrange, right? Is it like very organized, random, or very very random? And we need to know that. And in terms of particle motion, how they move, right? How they move, like like solid, can they move? The particle, can they move? Liquid, can they move also? A bit. Gases, can they move also? Yeah, very random. So we need to know all this in terms of words. Let's see, particle separation, the first one. Okay, for solids, the particles inside are tightly packed with no separation. Yeah, because there are no spaces, right? So they are just constrained in their own position. So it can only stay in their own position, not moving. For liquids, they are close together with some separation. Yeah, some separation because there are some spaces. There are still spaces. For gases, the particles are far apart. Yeah, because there are so much of spaces, right? Okay, so this is in terms of particle separation. So in terms of particle arrangement, the solid inside the particles are organizedly arranged. Organized pattern, we say. So because there are so much, so no spaces, so they arrange nicely like this. So in liquids, the particles are loosely arranged because they got some spaces. So in gases, the particles are randomly arranged because they got so much spaces, they can arrange whatever they like. So it's randomly arranged, no specific pattern, right? So in terms of particle motion, the solids, okay, we see the solids, the particles are vibrating in fixed position and unable to move freely. Yeah, because there are no spaces, though they cannot move at all. So they can only vibrate in their own position. So for liquid, the particles slide past each other and move in random motion in the box. Because they got some spaces, so they can move a bit, move with random motion a bit. So they can slide past each other. So they can still touch each other, not like gases or later gases. Okay, the liquids they can still touch each other, slide past each other. I say. So this is liquid. For gases, it will not touch at all. It will just collide. Alright. So it can move rapidly and freely in all directions, up, right, left, down, whatever it likes. So it can also collide with each other, like two particles collide together, and also container walls. Okay, can collide with container walls. So depends Okay, depends on their what they where they are going, what they are moving. Alright. So this is in terms of particle motion. So we recap a bit what we learned today. There are three states of matter: solid, liquid, and gases. So the distinguishing properties of three states of matter I stated here in a table form. So for solid and liquid, it has a fixed volume and it has a surface boundary. But for gases, it has no fixed volume and no surface boundary. So for solids, it has definite shape. For liquids gases, it has no definite shape. It takes the shape of the container. So for solids, the particles are tightly packed. And for liquids, the particles moving around slide past each other. So for gases, the particles move around freely. So in terms of these structures of the solid, gas, liquid, in terms of particle separation, arrangement, and motion, I also put it in the table form. So these are the summary lah. Okay, I summarized the notes just now into a simple table, so you can read it yourself, right? Okay. However, substance don't always stay in one state, right? Not always stay in like solid or not always stay in like liquid. It can always change to another state, like solid to liquid, liquid to gas, gas to solid again, the solid to gas again. What is the factor that causing the change of state and how? Yeah, a bit of spoiler. Okay. Actually, the temperature. The temperature is affecting. Like if you give heat to solid, it will melt, become liquid. So the process is called melting. Then change of state to solid to liquid, and the process is called melting. And what causing it? The temperature.